Hi, everyone. Thank you very much for attending this webinar, this second webinar of the project on embedded digital control of power electronic system funded by Innovate UK in collaboration between Teesside University and Sheffield Hallam University. Can you go to, yeah. So the project is, as I mentioned, that this webinar is a part of the series of other webinars and to build the skills and awareness on embedded digital control of power electronic system, which is funded by Driving the Electric Revolution Innovate UK funding. If you go to the next slide, please. Yeah. So you can see that this is the list of the events. So in 24th of February, we have a webinar on virtual prototyping of power electronic converters for embedded software and development. I'm sure some of you, they attended that one. And today we have the evolution of IoT in power electronics. And you can see the list for the other webinars. So we will be happy if we can join us on those series of the webinar. So now I'll give the floor to Gatika.
So, very warm welcome to everyone. I'm Dr. Gitika Agarwal, lecturer at TISA University. A brief introduction about me. I just joined the TISA University 5 months ago. Previously, I have worked at Nottingham Trent University as a postdoc on European Union Horizon 2020 project. And prior to that, I did my PhD from Northumbria University, Newcastle upon Tyne in electronics and communication engineering. The title of today's webinar is Evolution of IoT in Power Electronics, focusing on the recent advancement in key technologies for sustainable smart cities. So the outline of today's presentation is, we'll start with a brief intro of the research group and research center. I'll give some brief introduction about Industry 4.0 and IoT, and then we'll do some polling through Mentimeter. Thereafter, we'll move on to wireless networks, 5G and beyond with some general information. And then thereafter, sustainable smart cities and applications of IoT in power electronics in context to smart homes, smart grid, smart vehicular communication, and then followed by the future prospects. Okay, so first of all, research center and research group at TISA University I belong to is sustainable engineering and smart energy management, power conversion and control group. The leads are uh, Professor Meher, like Associate Professor Meher, Dr. Ruben, Professor Michael, and Dr. Adam. I would also like to thank the organizers of the project team, uh, Associate Professor Meher, Dr. Ruben, Dr. Musabau, and Dr. Imran for giving me an opportunity to present in the webinar today. So we'll come to the Mentimeter polling in few seconds. We'll start with the Industry 4.0 and technologies first. So first of all, what we understand by Industry 4.0 and where does that came from? The Industrial Revolution started in 1784 with steam power engines and then moved on to mass production and electricity around 80 mid like 1870, followed by automation, computers and electronics in 1969, known as third industrial revolution. Right now we are in industry 4.0, which is known as which comprise of cyber physical systems, internet of things and networks. So what do we mean by Industry 4.0 in detail, and what technologies it comprises of is like artificial intelligence, Internet of Things, which we're going to mainly focus on today in context to power electronics and sustainable smart cities. Another technologies which are in Industry 4.0 or in Industrial 4.0 revolution are integration, simulation, advanced robotics, big data, most probably when we talk about Internet of Things, we are collecting so much data through sensors and sending so much data. So their big data comes into play. Augmented reality, additive manufacturing like 3D printing, cloud computing, and cybersecurity, such as cyber attacks, privacy, and security. But we'll focus today on Internet of Things. Um, so let's move on to IoT growth trends. So what do we actually understand by IoT? IoT means like anything or our everyday object is connected through the internet. Now, how does it impacts the data rate and the uh, that like our internet usage depends upon um, let me take you through these two graphs. If you look on the top left graph, on the x-axis we have got years, and on the y-axis we have got traffic volume. EB stands for exabyte per month. And if you look at the bottom left graph, on the x-axis again we have got years starting from 2020 to 2030, is a 10-year gap, 10-year data. And on the y-axis we have got traffic volume per subscription. So we are comparing traffic volume per subscription to the traffic volume per month. If you look on the top right, we have got the table. So we are looking at the top traffic volume over here and traffic per subscription. So if we compare the data for the 10 years for a decade, let's compare the 2020 to 2030 where we are moving forward to. So traffic volume for 2020 was 62, which is shown in the top left graph over here. And if you look at the predicted traffic volume data for the Internet of Things in 2030 is 5016 exabyte per month, which is 670 times the data which we were using in 2020. So it is clearly too much of data, and how this data going to affect the data usage or our wireless networks or devices which are connected over the internet. We will be discussing that in next few slides through wireless networks or 5G, because we all have come across a situation, isn't it, once in a lifetime, or sometimes we say that okay, the internet is not working very fast. I want let's switch. It's time for me to switch to 4G now or 5G now. And why does that happen? Is because of this data traffic. Let's take another example from a day-to-day life. When we drive to work in the morning, let's say we have a lecture at 9 o'clock in the morning, and pretty much eight half eight is very busy traffic hour. Uh, so during the weekdays, like especially on Mondays, if we are stuck in the traffic, then we are late. So same thing happens with the internet data usage as well. If there is too much of traffic, we won't get the highest speed or the data which we need. So that affects the demand of the end users. How that can be compensated is through some of the networks which we're going to discuss in next few slides. So let's now move on to IoT connectivity. We have understood what is IoT. It stands for Internet of Things. It connects couple devices or many devices to each other through the internet. But what does that mean in terms of application? For example, when we talk about home, um, or industries, automotive, agriculture, military, medical, environmental, retail, and many more. So let's start by medical first of all. Like we say, talk about smart healthcare or medical appliances and all. So first thing is wearable fitness devices, easily connected through IoT. Then we have also heard about the word e-monitoring, e-health monitoring records. Then, if we come on to the agriculture, we have been discussing or we have come across the term a lot like smart agriculture, smart farming, crop management, soil analysis, which can help the farmers a lot during the agriculture part of their work. When we talk about automotive, autonomous vehicles, optimized traffic flow, smart parking is a very common area where IoT has played a major role. um, if you look at the smart home, like smart temperature control, isn't it? Optimize energy use, smart meters. They are also, if they most of the appliances in a home are connected to IoT, and they can help us with optimize energy use. Um, Then there are environmental applications, retail applications as well, industrial application, very, very common and very important, machine to machine communication and quality control. Um, there are also some application in industrial Internet of Things like collaborative robots, human to robot communication as well. But that's part of industrial Internet of Things. We'll just stick with in the Internet of Things today in this webinar. Um, if you look on the top right image over here, it says like IoT driving power and connectivity requirements. So we have talked briefly about variables. We know we have talked about retail, enterprise, QoT, and surveillance, tracking, our homes, and smart infrastructure. All these devices which are connected to IoT are consuming to some extent, some power, isn't it? And how that power can be minimized or how that energy can be minimized. Um, we're going to look at that in the later sessions in application part. So let's discuss about about some wireless networks. Um, so the same example which I have just given a couple of minutes ago, that when we are typing something or we are trying to connect to the internet, sometimes we are unable to connect to the internet because of the traffic issues or data usage problems. So we our first thing we comes to our mind is, okay, I need a high speed internet. So from where does that come from? Okay, so the mobile networks have started from first generation, second generation, third generation, fourth generation, and we are right now in fifth generation. There also talks about sixth generation, and there already been a lot of research going on towards the sixth generation. But let's stick on to these parts at the moment. So for the what was happening in the first generation mobile networks was we were only allowed to transmit voice or just the data. Then it messages were added to it, and then it was known as second generation mobile network. Then, on top of that, video calling, gaming were added to make things easier. So then that was 3G in around 1998. And then we had 4G, which was faster than 3G. Like we can upload videos, we can play game much faster, we can stream the data, we can send text, we can connect number of devices together. But now, right now in 20, since 2020s, we are in 5G, which have been talking about like exabyte data per month, highest data speed, Internet of Things, all this comes under 5G. But what about when 5G has also exhausted? Because we since in the last couple of slides we have looked at like by 2030 the data rate or traffic volume will increase to 5016 exabyte per month. To compensate the demand of the end users, there's a lot of research already been going on to move towards 6G mobile networks as well. And See, if you look at the x-axis, we have got years, and on y-axis, we have got innovation, which means like moving from 1G, 2G, 3G, 4G, 5G, and 6G, and so on. Um, there are some years left over here. It will depend upon the time, like when we get 6G properly, and then we are moving on to further generations and or not. Okay, so before we move on to next part of these slides, let's go back to the Mentimeter. We'll do some polling to understand some of the questions and to get you into the momentum. So what I want you all of you to do is, if you can copy this link or click on this link, then you should be able to access some of the questions on Mentimeter. So your first question is, what is your vision for sustainable smart cities? So is everyone able to access these questions? Perfect. Great. Okay. I'll give you a couple of minutes. Like what it comes to your mind when you think about some sustainable smart cities? Yeah, please keep on typing. Yeah, go ahead. Yeah. So I've got connectivity here, energy efficient. It's anonymous, so I don't know. Nobody knows who is typing. So don't worry about like your name will be disclosed. It's anonymous. So feel free to type what comes to your mind when you think about sustainable smart cities. Okay, carbon neutral, no traffic jam. Perfect. Like same thing we were talking about traffic. Okay, internet, easy transportation. Good. Energy efficient. Okay, energy infrastructure. Flying vehicles. We'll give one more minute, and then we'll move to the next question. Okay. Any more thoughts? Any more ideas? So I can see over here there are 14 answers, like 14 replies. Okay, so let's move on to the next question. Our next question is, which of the following has major role to play in sustainable smart cities, 5G and beyond, power or IoT? You should be able to select any one of them. Okay, so are you getting the question now? Perfect.
Yes, I do.
Yeah, perfect. So we'll give a couple of minutes to this question as well. Like when we talk about sustainable smart cities, we just had first question. We were talking about energy efficiency, smart transportation, a number of factors. So based on that, what do you think that which of out of three, 5G and beyond, power and IoT has got a major role to play in sustainable smart cities? Okay, let's go to the next question now. Perfect. How many now it what is asking you is how many GB is your internet usage per month? Like how many GB data you use per month? Like usually 10 gigabits per second. Okay. Okay. All right. So let's go move on to the next question. Oh, they're still typing. I'll give one more minute. 660. Okay, so your last and final question is how many of your devices, such as laptop, mobile, combined together connected to the internet right now? We'll wait for a minute. So 5 of them have said like they are connected to laptop and mobile combined together more than 4. 11 between 2 and 4, and less than 2 is only 1%. So quite a lot, like we use laptop, mobiles, data usage, internet, isn't it? Um, okay, we'll give a couple of seconds more and then we'll move on. So I'll share the results later on. So while I'm moving on to the next slides, we will discuss all of this in detail one by one. That what was the benefit of discussing this right now? These 4 questions, which we have to have done the polling for. Like, what do you mean by sustainable? What is a vision for sustainable smart cities? And how many data usage and internet devices are connected? So let's move on to 5G or 6G or green communication. Before moving on to Mentimeter, we talked about uh, we are right now in 5G, but by 2020, it is expected that we might need 6G as well due to huge data rate um, demand from the end users because of Internet of Things, smart homes, smart connectivity, sustainable smart cities, smart world, because everything is getting connected together through Internet of Things. We have heard about industrial Internet of Things. We've also heard about industrial we have heard about Internet of Medical Things. Then there is also Internet of Underwater Things, energy Internet of Things. So lot of Internet of Things, like everything is combined together just to ensure that we can like minimize the uh, power being used and make the devices more energy efficient by connecting them to one another. So in that aspect, when we're talking about the 6G, what we are looking for, um, we need a spectrum where we can have use a device so we have access to, like for example, this is the frequency spectrum on the top left over here. We have got the wavelength, got the frequency and the slots. We are all familiar with infrared light spectrum. We are all familiar with ultraviolet light spectrum as well, but the visible light spectrum is license free. um, it is also known as green communication. uh, what we mean by visible light is like right now we are sitting in our rooms. The lights, LED lights on top of our ceiling can be used not only for lighting, can be used for communication as well, data communication. uh, so pretty much like very easy. You have got the infrastructure available, you have got the spectrum available, just directly use that for communication. Like for example, if in your office room you have got a refrigerator, you got the microwave, you got your laptop, mobiles. Like right now, a couple of minutes ago, we were talking about how many laptops and mobiles you're connected, combined together, connected to right now. Most of them said like between 2 and 4. Couple of them said like it's more than 4. So the same thing, Internet of Things, using the ceiling floor lights infrastructure available, we can connect them through Internet of Things directly and save the energy. The potential applications of VLC on the top right image over here, indoor localization, then healthcare, uh, airplanes like the lightning on the ceilings can be used for data communication. In office, same like we can see the lights from the ceiling can be used for data communication and Internet of Underwater Things. Then vehicle to vehicle communication, like we have got V2V stands for vehicle to vehicle communication, I stands for infrastructure to vehicle communication. So we have got the street lights, then we have got the vehicles or cars, we have got the headlights. They can be used for communication either between vehicle to vehicle, like cars can communicate with one car through headlights or LED lights, and then they can also communicate to infrastructure through lights. So pretty much straightforward, very easy to use. Spectrum is available, no extra modifications needed, which and that's why it forms part of green communication and 6G. The extension of VLC is optical camera communication. So right now, in front of you all, you have got your laptops, you got your mobile phones. In your mobile phones, you have got a camera and you have got the screen. That screen and camera can be used for bi-directional two-way communication to send and receive data directly. You can use your laptops as well. Like we got a camera, we got a screen that could be used for sending and receiving the data directly. I have used OLED screen as well before sending the data for EEG monitoring. Um, if someone wants to go and read them in detail, they can go for follow these some of my papers as well. There's also a thing called multiple input multiple output configuration, which is also known as MIMO. Same thing if you are in your office. If you want to connect couple of devices, same like application of Internet of Things, want to save power, and then we can use multiple input multiple output configuration with these ceiling lights or with the laptops and these cameras, and then you can save energy and power and can enhance the data usage through 6G or green communication. So now we have talked about 5G, we have talked about IoT. Now let's look at the application scenarios of both 5G and IoT. So we are familiar with smart sustainable cities. We have discussed that question previously as well in Mentimeter, that what is your vision for sustainable smart cities? So someone said like energy efficiency, then there was options like of healthcare as well. We have looked at smart agriculture as one of the potential applications as well when we for sustainable smart cities, smart grids, power efficiency, power electronics, IoT, connected cars. They can be connected through Internet of Things, through smart grids, smart home, wearables, um, like Internet of Medical Things. So all these forms the part of 5G Internet of Things application scenarios. But when they are combined further through optical camera communication or through millimeter wave communication or through micro LEDs, they will be part of 6G communication through artificial intelligence and all. But that will be beyond the scope of this webinar. So we'll stick to just few basic and general information for the time being. So our focus today in this webinar is towards sustainable smart cities in context to IoT in power electronics. So let's move on to that. So we have already discussed a little bit part of this, that what things come to your mind when you think about sustainable smart cities: electricity supply, energy efficiency, uh, water supply, sustainable environment, good health and education, affordable housing, transport, sustainable transport, smart environment, smart buildings. These are just few basic things. There could be more things like based on your application scenarios you can add to that, but these are few of the basic needs for the sustainable smart city. So when we talk about IoT and power electronics, everything is connected through power, isn't it? And then when everything is connected through power, there comes energy efficiency. And we have right now discussed that IoT means connecting our everyday devices through the internet. When we are connecting so many devices like laptops, mobiles, and many more devices through power, the data usage or the power going to increase, both going to increase, isn't it, simultaneously? So how we can minimize the impact of it for the data usage? We have discussed like we are moving towards 6G as well, but for the in terms of power, there are aspects of energy efficiency, and another aspect of that is smart grid. Uh, Smart grid forms a two-way communication between the power supplies and the consumers. Um, it can be used for both transmission and distribution side by side. It's unlike the traditional grid. When combined with IoT, it can also be used for monitoring, automation, light tracking, and control purposes. So if you look on the top right image over here, we have got some of the smart grid or power generation sources. Then we've got the control center, and we have got some consumers like electric vehicle. We all are familiar with it, isn't it, nowadays? And smart homes, um, smart city, which we have discussed right now, industrial plant, energy storage, and then we have got this all as part of the smart grid, electrical grid for the future. Um, we have got the wind power plant, thermal power plant, solar power plant. So all they could be used in different application scenarios as well, based on what our needs are. The next aspect of IoT in power electronics can be taken from smart vehicular communication. Couple of slides ago, we talked about VLC, isn't it? Visible light communication, or using the ceiling lights for communication, and in addition to illumination. Uh, there we discussed about vehicle to vehicle, like one car communicating to the another car. So how that could be done is like that could be done easily through smart grid as well. Like we have got vehicle to pedestrian communication. Then we have got vehicle to vehicle communication over here. We got vehicle to infrastructure communication, which is towards the roadside units or smart grids. Um, then we have got vehicle to grid communication over there. So all these are connected through Internet of Things. Then we have got vehicle to home as well. There was one of the scenarios like, and then uh, these could also be used to, like if there is vehicle to vehicle communication, these could also be helpful in preventing accidents. There has already been a lot of work done in vehicle to vehicle communication on VNets and also increasing the high data rate. But right now, the more focus is on towards how we can work towards vehicle to grid communication and vice versa in terms of in terms of energy efficiency, uh, while we are moving towards 6G. So that's another aspect of IoT in power electronics where smart vehicle communication plays an important role. Then very important aspect, smart home. We all want number of things at home which are pretty much easy to use, connected to Internet of Things. But again, the same concept of IoT and power electronics comes into play. The data usage, electric vehicles, fuel cells, LED light, energy efficiency, monitoring, and how that all can be combined together is another aspect. Like for example, our modern homes are loaded with computers, TVs, which are powered through power electronic circuits. Then the application in homes could be solar power, wind power, electric vehicles, based on our needs and requirements. Um, So now we have discussed about some of the aspects of power electronics and IoT and 5G. Now where we are moving from all of these, the future prospects are 6G communications because we are already in 2023. By 2030, we are expecting the data to reach to 5016 exabytes per second per month. If you look over here on this image, we have got UAV, which is known as unmanned aerial vehicles. And then we have got underwater communication over here. We have got FSO, which is also known as free space optical communication. Then we have got software defined network, BCI, which is also known as brain computer interface. AI stands for artificial intelligence. Um, then M2M machine to machine, M2H machine to home, then robotics and automation. Then these are all MIMO base stations. If you look at the image at the bottom over here, which says smart home, you can see over here is written VLC, which stands for visible light communication. It justifies the same scenario that the lightning or the LED lights over the ceiling can be used for communication. So you are sitting in your office or home, You got the ceiling lights on the top that is used for communication. Then on the top left over here, you see there is a LCD TV or tablet with a camera that's used for communication. Then there's a mobile phone over here that's also used for data usage or mobile communication. So all these can be used for communication using VLC or optical camera communication. So it's a two-way communication, bidirectional communication, no extra hardware modification needed, no extra cost needed, entirely energy efficient, and fits well into our end user demand of IoT, power electronics, and 6G or 5G. Um, so there are a couple of abbreviations over here, like cellular user requirement and virtual, augmented, mixed reality. All these to some extent play an important role when we are moving towards 6G. Um, and we're talking about wireless networks, like for example, e-health remote monitoring. Um, we talk about like wireless networks a lot. Everybody wants like remote monitoring, isn't it? At ease through Internet of Things. For example, if there's a farmer wants to analyze his fields late in the night or about the weather conditions as well, or anything related to his farm, he can connect directly, use some sensors and can connect them directly through Internet of Things and can assess them through home. Doesn't have to go later in the night as well to the farm. So smart farming plays an important role over there in context to Internet of Things. um, then there comes smart city. Again, like we have got grids, we have got visible light communication, we got autonomous vehicles where we are moving forward to, like we are moving towards electrical vehicles and autonomous vehicles, isn't it? So again, the power electronics and IoT and artificial intelligence and 6G plays an important role in these kind of communications. We have heard about unmanned aerial vehicles. Again, forms another aspect of autonomous vehicles, but in air. Um, so these are few of the concepts where we are moving towards in terms of future. Um, we need smart sensors, smart controllers, artificial intelligence, smart energy meter plus IoT can be used and combined together uh, for smart homes, energy efficiency. Same goes for power electronic converters plus with IoT could be used for energy monitoring, for energy efficiency. Then again, smart monitoring through IoT and power electronic devices using 5G and 6G. Okay, so let me take you through one of the quick video, very small video of 1 minute, which one of my project students or project team, we all together have worked on it, smart healthcare system using Raspberry Pi. Let me see if I can play it right now. Okay, so what's happening over here is it's a Raspberry Pi module. Is everybody able to able to view this video? Okay, so what's happening over here is like it's a smart healthcare system. They have designed a smart health helmet design using Raspberry Pi. Uh, so they have got these four sensors over here on the left. So what happens over here is like if you apply extra pressure on these four sensor, the color on this module will change. So how it works is, let me take you through the video. So the force is highly applied, the color of the module or the lights have changed to red. So it's all about programming. The programming bit will also come in just a second. Okay, so idea behind this project was to design a smart healthcare system using Raspberry Pi. I think this might. Okay, using Raspberry Pi, and what we came up with was like smart helmet design. So if the force is applied, or if the rider has accidentally fallen from the bike and there's an extra pressure on it, so based on that, the color of the module changes, or the LED lights changes. So it was designed by first and second year students, supervised by me during the grand challenge. I think it was in 2021 in my previous job. But it's a very good application of smart healthcare system using Raspberry Pi and embedded systems, um, which I wanted to share with you all today. Okay, so quickly we are moving towards the end of the slides, and time is also running short. So quickly I'll go through my research areas and my research focus, which I am involved with my former colleagues as well. Internet of Things, Internet of Everything, where we are connecting vehicles, devices, underwater communications all together. Then optical Internet of Things, where we are talking about optical camera communication combined with Internet of Things. Unmanned aerial vehicles and underwater communications. 5G and beyond, which is the main area like I'm working on with my former colleagues in context to light fidelity and visible light communication, optical camera communication, to design hybrid communication systems for smart homes and smart offices. Then smart cars. I've already had one of the papers published in it. Then vehicle to vehicle communication, security and autonomous vehicles, in which I'm also working parallelly in context to artificial intelligence. Um, Designing real-time system prototypes and using camera communication, image processing, and artificial intelligence. Some of my profile links are like Google Scholar, then my academic YouTube channel, LinkedIn, and ResearchGate. You can easily access the papers or the research work through these links. So some of the key takeaways from today's webinar are like how, just to make it in simple sense, like how the Internet of Things play an important role in power electronics in context to applications such as smart grid, smart vehicle communication, smart homes, when we are moving towards 6G and such as sustainable smart cities. Like for example, when we talk about smart grids, they can help significantly in the measurement, control, and monitoring of the physical parameters in power grids in comparison to traditional grids. So these are a couple of takeaways. Um, Thank you for your kind attention. This is pretty much right time, 10 minutes for the questioning session.
Thank you very much, Yatika, for your time and for the presentation. Any question?
Hello everyone.
Yeah.
Good morning. My name is Soka for goodness sake. Thank you for the presentation. But I also want to ask, when we talk about sustainability in developing all these technologies needed, is there any environmental, because we are moving towards, I could see we are moving towards green communication. Let me use the word. Is there any environmental impact this technology has to play on us?
That's why we are moving. Thank you so much for the question. When we talk about green communication, it definitely has an impact because we are talking about net zero, decarbonization, emissions.
Emission by 2030, yeah.
Where target is 2050, but when we are talking about 2030, when we are moving towards 6G, specifically when we are using visible light communication, which is a green communication. Uh, so based on all the scenarios, it is like green communication can be used straightforward. It is available to us. We have got the infrastructure available, and I have worked on a couple of projects with students, like in last few years on the projects, on these kind of projects, smart home automation, like home automation and all, Internet of Things, a lot. So it's pretty much straightforward and easy in green communication.
Thank you. Any other question? Yes. Ajahn.
Yeah. Hi,
Hello.
Gitika. Thank you for giving an interesting talk. My question to you is for this IoT things, can you see some link or application in the manufacturing industry? Can you see something about it?
That's not directly my area, Shinjin, but based on the applications of IoT, um, if you talk about manufacturing, if you're talking about 3D or monitoring purposes or in construction and all, there is certainly IoT has got loads of applications. One of the biggest application could be of energy Internet of Things. I came across that word couple of days when I was going through when I was research papers and all. So that's not directly my area, but based on what I have come across for the IoT, I would definitely say there would be some applications for IoT in manufacturing too.
Yeah, okay, thank you.
Any other question? Maybe I can ask one. What is the differences between the IoT and the IIoT?
Um, IoT stands for Internet of Things and IoT stands for Industrial Internet of Things. So what happens is in Internet of Things, we can everyday objects are connected to the internet through sensors and all. But in Industrial Internet of Things, appliances of industries are connected through Internet of Things, like for monitoring or for control of automation purposes based on the industrial applications.
I just would like to mention that this presentation, it will be strongly linked to the next webinar. So in the next webinar, we have an industrial presenter from NADIC Control Techniques, and we'll look at the drive system. It is more specific, if you like, power electronic application, and we'll link that with the industrial Internet of Things. So that would be a good takeaway, as Gatika mentioned, and an introduction for the next webinar. So please keep watch our LinkedIn space that for these webinars and the event Bright as well. It is already there if you want to register and attend the next webinar, which is again a part of this series of the webinars that we provided in this project on the power electronics. Any other questions?
There's one question. I know he's my student, Ali. Can we use IoT to monitor power converter losses? Ali, I mentioned in the advanced practice session as well, power converter is not directly my area, but yes, for monitoring purposes, IoT can be used. But we can look into more detail about that area. I know that's your area and you want to discuss more about it with me. We'll pick it up in tomorrow in the session.
Actually, I can maybe say something about this IoT here. If we look to the power converters, so we can use those as a IoT sensors that we measure the current voltage of the power converters, and from these two measurements you can work out the power, and then you can find the losses. Also, it can be used for the communication between the control system and power converters, and that's another applications of the IoT in power electronics circuits and converters. Okay, so I think there's another question on the chat, Gatika.
Obviously, there will be challenges. Is there any risk regarding the IoT in power applications? Yes, there will be challenges, but it depends upon the applications as well. I think we didn't discuss about the challenges today in the webinar in detail because that's another a long like webinar in that aspect. But yes, there are challenges and risks which we have to look into when working in those areas.
There is another question from Kevin.
Oh, is LIDAR a sort of optical communication? Um, Not directly, I won't say that, but yes, there are there is, it involves laser, isn't it? It is an optical communication.
Okay, I think that's it. We'll just close that session. And thank you very much again for attending the session. And thanks, Gatika, for your time and for your presentation. Thank you very much. See
Thank you,
you
everyone.
in the next
Appreciate it.
webinar. Thank you very much. Thanks.